ITBD20 project title, the microgrid energy management system based on the non-intrusive load monitoring via multitask learning. So it is basically this project involves the energy management system in our homes, okay, homes or apartments. So the enormous amount of data which are stored in the data centers where we'll get it from the data sets, okay. So it basically stores all the energy consumptions in a day, in a 1 month energy consumption, 1 month of each flats, okay. So we'll be analyzing that, analyzing and predicting these past datas, past datas to future expense, okay, by following a pattern. So the analysis is carried out using big data and prediction with Python, okay. So the existing concept here is MySQL. There are various drawbacks inside it. One of it is data limitations and high processing time. The third one is data recovery. That is, there won't be any recovery after data loss. And the maintenance cost is very high. High. So the proposed concept we were using is Hadoop, which is a Apache software foundation. Okay. It basically has many tools. Example, Scoop and Hive. We'll be using that. So the techniques involved in Hadoops are clustering, joins, partitions, and bucketing. We'll be using that for our data analysis. So the advantages here is there won't be any data loss problems. That is, after you store the data inside the cluster, okay, it will be basically be replicating inside all the servers in the cluster. So even if you computer got malfunctioned, you can retrieve the data from the other resources, okay. It is also scalable where you can add other computer easily, and the amount of systems inserted in the cluster, the lower will be the data processing time, and this is also cost effective, so that you won't have any huge maintenance cost. And the MySQL, it is a database management system, and after it goes above 2 GB, it became absolute. So there won't be any huge processing time even for a simple calculation, okay. So the techniques involved in Hadoops are HDFS for storage, MapReduce for processing. You can use parallel processing in the MapReduce, and Hive for analysis, Python for the prediction. This is the architecture here. Once you give a query for the data to be retrieved, it will be going for the map produce, and after that it will go for the HDFS. So the data retrieved will also be again processed using the map reduce, and it will be shown in the result. So the real time example of Facebook and Twitter. The future enhancement is going to be Spark with the live streaming data analysis. Example, stock market. The software used is MySQL, Hadoop plus Linux. You'll be combining that into the Cloudera OS and Python. We'll be using that in the Jupyter environment. Okay. This is the minimum requirement you need to run for the big data process. Okay. Thank you.